I am going to tell you about electrochemistry. Electrochemistry is a part of chemistry that can deals with the relationship between chemical energy and electrical energy. Electrical energy converted into chemical energy. Example is electrolytic cell, and chemical energy converted into electrical energy. Here electrical energy is converted into chemical energy, and in second process chemical energy is converted into electrical energy. An example is galvanic cell or voltaic cell. And conductors. What are conductors, or what is a conductor? Substance which allow electricity to pass through it is called as conductor. And conductors are classified into two types basing on the nature of conductance. One is metallic conductor and other is electrolytic conductor. Metallic conductor is also called as electronic conductor because as it allows the flow of electrons, and electrolytic conductor is also called as ionic conductor as it allows the flow of ions. And metallic conductor is in solid state and electrolytic conductor is in molten state or aqueous solution state. Example of metallic conductor is Fe, that is iron, copper, sodium, silver, aluminium. And here, what is an electrode? If any metal rod is dipped into its own ion containing solution, then potential difference will generate between the metal rod and solution which is in contact with the solution. This arrangement is called as electrode. Here, for suppose I have took aqueous solution of Cu, that is Cu plus 2 SO4, and this is a Cu metal rod. Then a potential difference is generated on the part of the rod which is in contact with the solution, and this type of arrangement is called as electrode and is called as Cu electrode. Similarly, zinc electrode. Similarly, the zinc electrode. And now we will be going to learn about the differences between the metallic conductor and electrolytic conductor. In metallic conductor, conductance is due to the flow of electrons from negative terminal to positive terminal, whereas in electrolytic conductor, conductance is due to flow of ions towards the oppositely charged electrodes. During the conductance, chemical changes are not observed in metallic conductors, but whereas in electrolytic conductors, during the conductance chemical changes are observed and chemical substances are deposited. No chemical substances are deposited in metallic conductors, whereas chemical substances are deposited in electrolytic conductors. With increase in temperature, the conductance will decrease due to the increase in resistance, but whereas in electrolytic conductors, the increase in temperature, the conductance will decrease. No transfer of matter takes place in metallic conductors, whereas in electrolytic conductors transfer of matter takes place. And now we will be going to learn about electrolytes. What are the electrolytes? Electrolytes are the chemical substance which can be dissociated into two oppositely charged ions in aqueous solution are called as electrolytes. And strong electrolyte, alpha is dissociation constant, and when dissociation constant is equals to 1, then it is called a strong electrolyte. Or we can also say that electrolytes which are completely ionizable is called a strong electrolyte. Examples for strong electrolyte is NaCl, HCl, KCl, NaOH, H2SO4. Or we can say that all strong acids and base. And what are the examples of weak electrolyte? The dissociation constant which is less than 1 is known as weak electrolyte, or we can also define it as electrolytes which are partially ionizable is also called as weak electrolyte. Dissociation constant alpha is equals to ionizable molecule by total number of molecules. And examples for the weak electrolyte are CH3COOH, NH4OH, NH4Cl. And resistance. What is resistance? The force which can oppose the flow of electricity is called as resistance, and V is equals to IR is the formula and units are ohms. Conductance, the reciprocal of resistance is called as conductance, that is C. Conductance is proportional to 1 by R, or C is inversely proportional to R, that is resistance. C is equals to conductance, R is equals to resistance. Therefore, when we are introducing a proportionality constant, C is equals to K into 1 by R, where K is called as specific resistance. And here units are ohm inverse or mho.